Hello students, I hope you all are doing well. In the previous videos, we started with the lesson representation of geographical features. So we'll continue with the remaining portion of the lesson and let's begin. Now in the first picture, you can see the earth and on it there are a series of lines and these are imaginary lines which are running horizontally and vertically. Now these lines form the grid system. In the next picture, you can see the part of a map where you will see the lines running horizontally and vertically, and these lines form the grid system. Now, what is the use of grid lines? Now, to locate places very easily on a topographic map, grid lines are used. On a topographic map, the vertical lines are called eastings and the horizontal lines are called the northings. Now in this picture you can see the network of lines. Now these types of lines you must have seen on the graph paper. Now in geography, the x-axis is denoting the eastings and the y-axis is denoting the northings. The grid references locate relatively small and more specific features on a map and they locate the exact point on the grid. Now grid references are of two types, 4-figure and 6-figure. Now 4-figure are those which indicate a single kilometer square on a map and 6-figure indicates a point within a square. In the 4-figure grid reference, the first two numbers indicates the eastings and the next two numbers indicates the northings. In the 6-figure grid reference, the first two numbers are the eastings, but the third number as it is given here is 4, so it will be 4 by 10th. That is, the division is 10, so it will be 4 by 10th. And the northings is 2, 2, but the third number will be 3 by 10th according to the divisions. Now the 4-figure grid reference, now each square has a grid reference which we get by putting together the numbers of the easting and the northings that cross in its bottom left hand corner. Always read from the bottom left hand corner of the square, first the eastings and then the northings. Next we come to the 6-figure grid reference. Now you should be able to divide all the sides of the square into 10 equal sections. By doing this, you can pinpoint locations within the square. These are called the 6-figure grid references. Now we'll see an example. We have to find out the 6-figure grid reference of the church. Now the church is in the grid square 2231. If we imagine that the square divided into 10 parts, the church is 2/10 further east and 2/10 further north. So the 6-figure grid reference will be 222312. The next we come to relief. Now relief show height and slope, spot heights, triangulation points, contours, layer and hill shading, cliff symbols. It is very difficult to show relief features on a flat surface as the surface of the earth is uneven and a patchwork of mountains, valleys, plains and seas are found. Hence, a number of methods which are descriptive and illustrative are used to indicate these relief features. Next we come to the methods to show relief of an area. The descriptive ones. It includes trigonometrical station and benchmark, spot heights, relative heights, then illustrative, which includes contour lines or form lines, heshor, hill shading, and layer coloring. The picture shows a trigonometrical station. Now, trigonometrical stations show height above sea level and are designated by a triangle followed by height. Trigonometrical stations are also shown on the topo sheet. They are found on hilltops and mountain peaks. They are represented by a symbol shown by a small triangle or a circle with a black dot inside. Now in this map you can see the trigonometrical station with the height written next to it. Next is the benchmark. A benchmark is a place where exact elevation is known. It is shown by BM on the map. Benchmark provide the actual height of the mark from sea level. They increase the utility of a map and they are used as surveyor's mark. These are cut in stone taking the form of an arrow. Next we come to the spot height. Spot heights show the exact height of a point above sea level on a map. They are always written in meters with a dot next to it. A spot height is indicated by a dot point and a number or a triangle and a height value. In the next picture, you can see a number in black indicates the highest point in an area. The next we come to the relative height. Now the relative height is the height of a feature with reference to the height of the surrounding land and not to sea level. It is represented by the height with a small r. Example 12r. Now let's see some of the examples of relative height. The first one indicates the relative depth of the river from the bottom, which is 8 meters. The next one indicates the banks of the river is 4 meters steep. The other examples indicate the depth, the height of wells, dams, ponds, then embankments and sand dunes. Next we come to the contour line. Contour lines are continuous lines used on a topo map in order to show points of the same elevation. Contours are lines that join points of equal height. Now it is shown by light brown or orange lines. Contour lines usually have a number attached to them, and this number indicates the height of the land above sea level. Contour lines are drawn in intervals that never change and never cross each other. Now the elevation difference from one line to another is called the contour interval. Now on the map portion below which is given, the contour interval is 20 feet. The horizontal distance between two successive contours is called horizontal equivalent. In the next picture, we learn about the steepness of the slope, and here we can see that the distance between the lines indicate the slope. When the contours are close together, they show a steep slope, but when the contours are wide apart, they show a gentle slope. But in case of waterfalls and cliffs, the lines are touching. Next we come to form lines. Now these lines are drawn where it is not possible to draw contours and there is a prominent relief feature which is lesser in height than the contour interval. Now these lines are similar to contour lines but have not been accurately surveyed and hence they do not show definite heights. They are printed in broken brown lines and are easily distinguishable from the contour lines. They help to show minor details which cannot be easily shown by contour lines. The next we come to hachures. Now hachures marks are short lines used for shading and denoting surface in relief and drawn in direction of slope or flow of water. They are drawn close together on a steeper slopes and wider apart on more gentle slopes. Now in the next picture you can see hachures. Next we come to hill shading. Now this method of representing relief gives to map an appearance. The location of the land is shown by light and dark shading. It is very suitable for small scale maps and this method does not show absolute heights. Next we come to layer coloring, which shows height on a map. The darker colors are used for the highest parts of the relief and lighter colors are used to show low-lying land. Now next we come to the gradient. Now gradient is the steepness of a space. It is expressed in the ratio between the rise in height and the length measured along the ground, that is the horizontal distance. Now we'll study the cross sections of different relief features. The first one is the convex slope. It starts steeply from the bottom and becomes more gradual at the top. The higher contours are wide apart while the lower contours are drawn close. The second one is the concave slope. It has a gentle slope at the bottom but a steep slope at the top. The lower contours are wide apart while the higher contours are drawn close together. Next we come to uniform slope. Now in uniform slope the ground has the same slope throughout. Uniform slope may be steep or gentle. In this, contours are evenly spaced. Next we come to terraced slope. It is also called the stepped slope. In this, the slope runs in the form of terraces. The contours run in pairs and the distance between two consecutive contours remain constant and then increases. The next is a spur. A spur is a tongue of land projecting from higher ground into lower ground. In this, the contours are V-shaped and the apex of V shows lower ground. Next, we come to a valley. A valley is a long, narrow depression with downward slope and the contours are V-shaped. Now, in a valley, contour decreases inward. Next is a plateau. A broad flat-topped highland rising steeply from the adjoining plain is known as plateau. The contours are closely spaced on margins and they show steep slope. There are no contours in the center. A conical hill rises uniformly from the surrounding land and has uniform slope on all sides. The contours are circular with uniform spacing. Then we come to cliff. Now, cliff is a very steep face of rock with considerable height, usually found at the edge of sea or lake. The contours run very close to each other and merge into one. Contour heights increase inward in a cliff. Next is a waterfall. It is a sudden and vertical fall of water over a top in the bed of river. The contours are spaced close together and may touch one another. Next we come to escarpment. Now in this formation, sides are sloping in opposite directions consisting of a steep or scarp slope and a more gentle or dip slope. The highest part is called the crest, and in this steep and gentle slopes occur together. Next is the ridge. A ridge is a high elongated hill. A chain of hills forms a narrow ridge. They often have sharp edges. For this, the contours are elongated. Next is a saddle, pass, and col. A saddle is a broad col or pass between two mountain peaks. A pass is a low possible gap through a mountain barrier, usually caused by erosion. It is also called col. Next, we come to a knoll. A knoll is a small isolated hill. It appears more or less round and is therefore represented by small, roughly circular contours. Next, we come to a watershed. A watershed is a divide separating the drainage or tributaries on the sides of a hill. Now, the contours representing the sea level, they are generally zero. Then, in case of steep slopes, the contours are very narrow. With this, we come to an end of our video. The remaining portion we'll complete in the next video. So, till then, have a good day.